Hi ladies and gentlemen, I hope everyone is doing well today. Today we're taking a look at gas equations. Right up top we have some information on gas pressure. It gives us two containers, container 1 and container 2. There's a couple things that we can tell from this. One, we know it's the same gas. We know it's the same gas because the shade of the molecules are the same. We know that the volume, the size of the box is about the same, and we know that we have more of the gas in container 2 because we have more dots in there. When you come to the information, the first sentence that's highlighted is it tells you what gas pressure is. Gas pressure is caused by the gas molecules that are bouncing off of the inside of the walls. The pressure is determined by the force pushing on the inside of the walls. It's related by this equation right here. Pressure equals the force divided by the area. Pressure is P in kPa, force is F in newtons, and the area is A in meters squared. It is important to understand how to manipulate the equation a little bit. So when I say manipulate, what I mean is if the force is very large, how does that affect the pressure? If you have a big number in the numerator, then your outcome will always be large. If you have a very large number in the denominator, then if you have a larger number in the denominator, then your pressure is smaller. That will be very important when you are answering question 1. When you're thinking about question 1, you have to determine, is it easier for someone on ice skates or someone with shoes to fall through a lake during the winter? So for our purposes, it's going to be the same person. That way the force doesn't change. The force is the person's weight that is pushing down on the ice. That won't really change within an hour or too much of a day with each other. But what does change is the area. So if you think about an ice skate on the blade, it has a very small area. You have a nice thin piece of metal that you're skating around on. When you have a shoe, you have a nice flat surface with a bigger area. So think about that. When you plug it into this equation, will a bigger area make the pressure be larger or smaller? And then do you think if you have a low pressure or a high pressure, which would be easier to fall through the ice? Really, really important. If you need to rewind, you can rewind and listen to how I described how big and small numbers affect the pressure. Question 2. Question 2, you're thinking about which container in figure 1 has the highest pressure. So when you look at these containers, remember that gas pressure is caused by the molecules that are bouncing off the walls. From these pictures, we can't really tell too much other than the amount of gas that we have in each container. So another way to ask this question would be which container will have more collisions on the inside of the wall. Make sure you explain your reasoning why that container will have more collisions. Question 3. So question 3, now we're heating the containers. We actually did this when we did the simulations. So please think back to the simulations, what happened as you were heating the containers when the volume couldn't change. Question 4, this information, we are using this data to answer questions 4, 5, 6, 7, maybe 8 and 9. I'm not sure how far it goes, but we are using this data for a while. So for question 4, we need to verify the equation that they give us is true when the volume is unchanged or constant. So this what I'm about to tell you will be really helpful when you're thinking about question 5. So it is in your best interest to pause question 5, read it, that way you can get the answer to that and you won't have to scroll back or rewind to find it. So remember guys, whenever the volume is unchanged or constant, the reason why it doesn't show up in here is because it's, just like I said, it's unchanged or constant. When it's not changing, it's not affecting the outcomes. It really is as simple as that. You will be asked a question similar to 5. Please don't overcomplicate it. But when you're thinking about question 4, so what we need to do is we know that the volume is unchanged and constant. We need to look at this data table and pick 2 trials where the volume is unchanged. So if you'll see here, we can look at trial A and trial G. For both trials, you have a volume of 3.2, so that is unchanged. So what I did down here is I just rewrote the equation. Where there's 1s, I wrote A. Where there's 2s, I wrote G. Next, we would just have to plug our values in. When we plug our values in, you'll see that pressure of A is 120, the temperature is 324.3. And then you do the same thing for G. Pressure is 225, temperature is 608. And then when you solve these, you only have to go to 2 decimal places. 0, you would see that 0.37 equals 0.37. So what you did here is you just verified. When the when the volume is constant, then the pressure divided by the temperature will equal each other for any trial. What I just did here in question 4 will be helpful when you're thinking about questions 6 and 7. Remember, guys, I already talked about question 5 a little bit. Make sure you rewind if you missed it. So when you're thinking about questions 6 and 7, so now we have constant temperature and constant pressure. So you need to look through these trials. Which 2 trials have constant pressure? Which 2 trials have constant temperature? Then, just like I did here, you need to plug the values in until you get an example to one of the equations I've given you matches up. This is how scientists figure out mathematical relationships. They just plug values in and try new things until stuff works out. Question 8. So guys, really important when you're working on questions 6 and 7, make sure you show all your work. You do have to use the equations a little bit when you are thinking about 8, A, B, and C. So A relates to question 4. The equation usually got is P1 over T1 equals P2 over T2. For B, this relates to question 6. P1 times V1 equals P2 times V2. And then lastly, C relates to question 7. V1 divided by T1 equals V2 divided by T2. So what you just need to think here is, as one of the variables change, how does that affect the other one? So you have the equations here, so even if you can't get them from the question from doing your work, you can still think about how changing the values will affect the outcome. If you need help with 4, 6, or 7, please just let me know. Question 9. Question 9 is very similar again to 4, 6, and 7. However, this case, we're looking at the combined gas law. So in this case, you have pressure, volume, and temperature. So here, nothing is held constant. So what you can do is you can pick any 2 trials, plug in the values, and you should get the same answer. Again, combined gas law, very important. Number 10. So number 10, this question is tricky. Whoops, I'll let it focus. So what you kind of need to remember is back to this figure. How did you know container 2 had more pressure than container 1? What is the only difference? The only difference between container 1 and container 2 has been left out of the information that is in table 1. See if you can figure it out. It is tricky. What is being held constant? And then lastly, question 11. Question 11, we are solving a couple of gas law problems. So to solve a gas law problem, you need to identify what's being held constant or what's not being held constant. Remember, guys, a quick reference to you can be over here, question 8, because we know at constant volume we use this equation, at constant temperature we'll use this one, at constant pressure we'll use this equation. When in question 9, when nothing is constant, we use the combined gas law. So then when we come over here back to question 11, first thing we need to do, constant temperature. So we know that we need to use the gas law that has constant temperature. Yeah, constant temperature, which is right here. P1 V1 equals P2 V2. So then we write it. P1 V1 equals P2 V2. What we need to do is we need to now identify some variables as the pressure 1, volume 1, and pressure 2 and volume 2. Make sure you stay consistent. Make sure you read and what it tells you. So it tells us that the gas expands from 4 to 8. So that means 4 is the initial, 8 is the final, or volume 1, volume 2. So V1 equals 4, V2 equals 8. Next, we continue to read. It tells you the initial pressure is 120. So again, that is P1. P1 is 120, and we need to find what the final value is right here. So now we can plug our values in. 4 is next to the V, 120 is next to the P, and then that is going to equal P2 times 8. Again, to solve this, this is just algebra. You need to divide both sides by 8. P2 is going to equal 120 times 4 divided by 8. I don't know that number off the top of my head, but I think you guys can solve that. So when you are thinking about B and C, make sure you identify what's constant, if anything is being held constant, and then use the appropriate gas law. Remember, guys, if you have any questions, please circle them, write your question down, and bring it to class. Hope everyone has a good day.